All right. So we were talking about activation energy, the need to have a certain amount of energy to get a reaction started, and then it continues on going. That initial push to get it moving. You'll notice in this particular equation that we have, this particular reaction that we are tracking, we have the reactants over here. The reactants are what you start with. The products are what you have at the end of the chemical reaction. You'll note that the energy level of the reactants here is higher than the energy level of the products. That means that during the reaction, energy is released from the reaction out into the world. It's called an exothermic reaction. It's sending the energy out. So, for instance, a really powerful exothermic reaction is dynamite going off, or C4. Another exothermic reaction is burning wood. You burn the wood. There's an exothermic reaction going on where the heat is coming out of it. Sometimes when there is a reaction, it actually the energy level of the reactants is lower than the energy reaction level of the products, that it ends up someplace up here instead. We call that an endothermic reaction, in that it requires energy to make the reaction happen. So you have to pour energy into it in order to make it happen at all. And usually the activation energy is even higher. It's always even higher than the final energy level of the products. Now, an endothermic reaction is pulling energy in from the outside in order to fuel the reaction. For instance, endothermic reactions, they pull heat energy out of the surrounding area. So if you were to have your hand next to an exothermic reaction, one that started with a higher level of energy in the reactants and went to a lower level in the products, then your hand would become hot because the energy being put out. But if it was an endothermic reaction, then you would feel the heat energy being sucked from the air around your hand into the reaction. The air around it would become colder. So an exothermic reaction produces heat and or other types of energy. An endothermic reaction sucks in the heat or other types of energy. So for instance, when you are sweating, yes, you are hot and you are sweating, but when the sweat evaporates off of you, it cools you down. That's because sweat evaporating is an endothermic reaction. It is sucking the heat energy off of your skin and out of the surrounding air in order to fuel the water, the sweat evaporating from your body. All right, enzymes, how do they do it? Well, they do it through basically pulling things together. You see this energy that's pointed in, this energy that comes in for the activation energy, that energy causes the molecules to move around more rapidly. That whole idea of starting out with that in a solid, the molecules are close together and just kind of sit there and vibrate a little bit. In a liquid, they whoosh around a little bit more. In a gas, they fly around a lot more. Well, what the energy that's put in here is doing is it's causing the molecules of the substrate or the reactants to move around more, bump into one another more, and increase the chances of bumping into one another in such a way that the reaction actually occurs. What an enzyme does is it speeds up that process by pulling the reactants together in a way that they will react quickly with each other. Now, the gray part here is the enzyme itself. The enzyme has something called an active site on it. That active site is shaped exactly like the reactants. However, when you're talking about an enzyme reaction, you call them substrates. So the substrate for the enzymatic reaction are the reactants that started out. Well, those substrates fit very well into the active site of the enzyme. So the first step in an enzyme is going ahead and pulling that substrate into the active site of the enzyme.